Hello everyone, welcome to mentorbuddy.com. This is your mentor Gurvansh, and today I am going to teach you about decision tree algorithm. So guys, till the last topic we have covered the EDA and data pre-processing in ML using Python. We have talked about the linear regression. Using the linear regression class, we solved the simple linear regression where we had one input variable and one output variable. We solved the multiple linear regression problem statement having six input variables and one output variable profit. Then we talked about a different supervised learning algorithm, the backward elimination algorithm, using which we were able to eliminate insignificant columns, yet we were able to increase the accuracy of the model or R2 score of the model. Now guys, when we talk about non-linear regression or non-linear data set, our linear regression is going to fail us. The reason for that is that the linear regression class is specifically programmed using the linear equation. So if we feed a non-linear data in that particular model, it will produce an error. So here we will be using the decision tree algorithm, which is a much more powerful algorithm than our linear regression class, which can work with both the linear regression and also the non-linear regression. Now the decision tree algorithm by definition follows a flowchart like structure or a tree like structure where each internal node represents a test on an attribute, each branch represents the outcome of the test, and the leaf node represents a class label. So what exactly happens in the decision tree is that we try to create a decision tree. We try to create a tree which starts with the root node. Depending upon the root node, we are going to create certain criterias on our attributes, different attributes. Now attributes over here are the input columns. Now depending upon the columns, we divide our data to predict the output. Now decision tree has three types of input nodes: decision nodes, chance nodes, and end nodes. So decision nodes are typically represented using squares, chance nodes are represented using circles, end nodes are represented using triangles. Now let's say we have this kind of data set which you are seeing right now on your screen. We have two input parameters, x1 and x2, input features x1 or x2, and the output y which we are looking for is the third axis which is coming outside of the screen like this. So x1 and x2 are the input variable and we are looking from top to bottom view, and y is coming outside of the screen towards us. Now guys, when we feed this type of data in the linear regression class, we are going to get an error, a huge error, and the accuracy will be very less. The reason over here is that the linear regression class cannot process this kind of data. Now to process this kind of data, what decision tree algorithm will do is that since it works by creating certain tests, work by dividing the data set, we are going to create certain tests on our different attributes. What will be the attributes over here? X1 and x2. So on these attributes we will perform different tests, divide our data set into different classes, different sections, and then we will solve those sections separately. So let's say I performed my first split of the data set with the help of the attribute x1, and I am doing the split where the values are less than 20 for x1 and greater than 20 for x1. So this was the first split. The second split, let's say I did with the help of the x2 attribute or x2 parameter, where the values will be less than 170 and greater than 170. Now here we can stop over here, but we still make few more splits to make it still more easier to understand or still more easier to predict the output. So let's say I made a third split with again with x2, where the values can be greater than 190 and values can be less than 190. Then there is the fourth split where x1 values are greater than 40 and less than 40. Now guys, while we perform these splits, the decision tree algorithm have different criterias to do so. For classification problem statement and for regression problem statement, we can have different criterias. Now this decision tree algorithm is one of the more advanced or more complex algorithm which can be used for both regression problem statements also and classification problem statement also, but the internal working will change. Here we are going to discuss about decision tree for regression. So when we talk about decision tree for regression, the splitting criteria we talk about is the variance calculation. So for all of these splits which we are doing, we select the splits which is by which the variance of the different sections is the minimum. So let's say when I made the first split, let's say the whole range is from 0 to 70 for x1. So when I selected the first split, what we will do, we will first try to get different classes with different splits. So our first will be x1 equal to 10, then 20, then 30, then 40, and so on. So let's say at x1 equal to 20, the sections which we had two sections on the left hand side and the right hand side. Let's say depending upon this particular value, the variance of both of the side was the minimum. So we selected x1 as the first split. Then we saw that this split on the right hand side is still very huge. So we used x2 to split our right hand side portion into upper portion and lower portion, again following the same variance notation, that wherever the variance value is the minimum, we will select that particular value as the splitting value. Moving on, so when we try to make this if we try to convert this decision tree internal working into tree, we will get this type of structure. Now first split was, one split was using x1 value, one split was using x2 value, one split was using again x2 value with 190, 170. Then we did the last split as x1 which is less than 40 or greater than 40. Now these are the chance nodes, and the triangles, as in the previous slide, the end nodes are represented by the triangles. Now what are these triangles? So these triangles represents the output of the y column depending upon all of these different sections. Now these different sections will help us to create different relationship between x and y values. So if you remember the linear equation, so here we will be forming a non-linear equation, but still we will have the coefficient value and the constant value different for different sections. Now when we get these different values, we take a average out of them to form our final equation. Now let's say from one section we got a single coefficient, let's say I got 300. From another section I got a coefficient of 67 for the same value. Now guys, see, there can be multiple coefficients. Since we do not know the exact number of the data set, that is why we try to show only one output value. So you can assume that n, there are n variable, and out of those n variable I am showing, let's say I am talking about x1, coefficient for x1. Okay, so let's say the coefficient for x1 from one class was 300, from some another section was 63, some other section was 1023, for another section it was 0.60 minus 64, then for another section it was 0.7. Now how will we get the final equation? To get the final equation or the final coefficient for the equation, we simply take the average out of all the sections to get the final coefficient values. When we get the final coefficient value, our final equation is created. Now what are the steps more? As we all know, we start by importing the basic libraries first, importing the data set and splitting it into x and y. Once we are done with this, we fit the decision tree model. After fitting the decision tree model, we predict the output and try to represent our data. Now here in this scenario, there will be another graph which I will show, which will be a more precise graph. So here in the Matplotlib library section, while we will create a graph, I will teach you an extra thing where we can increase the precision of our model, and I will teach you how to increase the precision of our graph while plotting a value. So thank you guys for joining us on MentorBuddy. I hope that this decision tree intuition is clear to each and every one of you.